Inverse functions and their relations. The basis behind inverse functions and how they are related is the swapping of their x and y values. So what we're going to do is we're going to go through two different types of functions, swapping x and y and then resolving for y. There's going to be something that we mention for the square root functions, but it's just going to be an introduction on how to swap x and y and then resolve for y. You can see here is a function h of x equals x plus 7. You can see that the very first step that I did was I rewrote, instead of h of x, I wrote y equals x plus 7. I think it's a lot easier to see a y there than it is the function of x. So whenever we see that y and we also see the x, you can see the next step is me swapping them. I rewrote the equation. Instead of writing y equals x plus 7, I wrote x equals y plus 7. This is going to be true for every function. These are going to be the first steps that you're going to do every time. And then to get y by itself, I subtracted 7 from both sides and gave me an inverse function of y equals x minus 7. Now, not all functions are going to be as simple as, oh, I can look at this function and I can automatically do the inverse by just taking the opposite of everything that I see. That's not the case. You'll see in the next section with rational functions that whenever you're finding the inverse, it's a little bit more of a complicated process, and you're going to see that, oh, it's not as obvious. Whenever you're dealing with any type of root function, there's going to be some stuff that changes. So that's going to come later on in a section several units from now, but I just wanted it to kind of be on your radar as just paying attention to radicals. Let's go through two problems and switch out the stuff, which would be the x and y, so we get the inverse of the function that we're given. So instead of g of x, I'm going to write y equals 2x minus 3. And this is a linear function, so it should be nice and easy and clean to swap everything and shuffle around. I'm going to switch x and y because we know that whenever we're doing an inverse, our x and y has flipped. And that's what I just did right there. Now we got to figure out what y equals. So get rid of the minus 3 by adding 3 to both sides. X plus 3 equals 2y. Now we divide both sides by 2 so I can isolate y. X plus 3 over 2 equals y. This is the inverse of this. And you can see, not necessarily as clear-cut and simple as going, oh, okay, well, that was minus 3, so it's plus 3, and then that was multiplied by 2, so I'm dividing by 2. Sure, it may look obvious, but go through the process and solve. Solve for y all over again after you swap the variables. Let's take a look at this square root of x plus 8. So I'm going to go through the same process, and you're going to see that anytime we want to find the inverse of something, this is the same exact process we're going to go through every single time, regardless of what type of function it is. So x plus 8. Then I'm going to switch my x and y. And since that 8 is on the outside, it's not part of the radical, I can go ahead and get rid of that by subtracting 8 from both sides. It's going to give me x minus 8 equals the square root of y. Now, to get rid of a square root, I need to square both sides, the inverse of what I'm looking at, which will give me x minus 8 squared equals y. Now, this is one of the things I just want you to have on your radar, because whenever transformations with all types of functions come up, and then we're determining, well, what does it mean when there's a plus 8 on the inside of the radical versus the outside of the radical? I also want to keep in the forefront of your mind that whenever we're swapping x and y values, that's also going to change the domain and range of various types of functions that we're going to be using. So just keep in mind that whenever we are finding an inverse of a given function, it's not only are we switching the x and y, but we're also swapping the domain and range. We've already gone over in a previous section what it looks like to have inverse functions with a table. In another previous section, what it looks like to have inverse functions on a graph. And all I'm saying is just keep in mind that whenever you have different types of functions, there are different types of properties that are going to change. Whenever we get into the sections for transformations of the different types of functions, we'll elaborate further.